Hi friend, this is a follow-up video, and as I promised, I will verify this remaining two conditions today. We have already seen about the matched load part. Today we'll do a short termination and a open termination, and lastly we'll show you an example of complex load also. So let's open our Serenade. So this is the circuit we have simulated previously. So let's delete this register and let's first simulate for a short circuit condition. So short circuit condition means our termination will directly connect it to the ground. So get our wire. Okay, perfect. So everything is done, and if you want to see about our transmission this transmission line, then today we were simulating it for 6 GHz. Last day we were simulating for 3 GHz, so let's try with 6 GHz today. So yeah, I need a functional generator also. See, in function generator today I need to change these steps because I am simulating for 6 GHz. And here our frequency is starting from 1 GHz to 5 GHz, and this third term is just a step, like in incremental step, in how many step our frequency generator will increase. So step, let it be the same, and let's change our starting point. So as we are dealing for 6 GHz, let's start from 4 GHz and go up to till 8 GHz. Okay, perfect. So let's analyze it. Done. Report S11 and dB. Before seeing dB, let's see the magnitude. And if you remember, for short termination ZL is 0, so magnitude of S11 should be 1. Phase will come later. Let's see for the magnitude first. S11 magnitude, add and display. And see, at 6 GHz we are getting 1. Perfect. If you want to see the spot frequency, like what is happening in this frequency only, then you can do one thing. Go here and you just, let me copy it, you just cut it, okay, and just give your required frequency. Then also it will work, but it will work for the spot frequency now. Perfect. Report editor, S11 and magnitude, add and display, and see at spot frequency, as from theory we know it should be 1 and we are getting 1. Perfect. Now let's see for dB. I think there is no requirement to see in dB because we know dB will be 0, but let's still see it. Add, let's delete previous one, display, and see it is 0. If I show you with my data marker, then it is showing 0. Perfect. So we are seeing in the spot frequency, like I am not using any range now to make you see the like clearly visible. So I'm using the spot frequency. Now the interesting part, let's see the phase part of S11. Delete previous one, select S11 and angle, and add. Before displaying it, let's see what theory tell us. Our theory tell us that it should be 180. Let's see, are we getting it? Display. And great, we are getting 180. Plus minus has no value for 180 degrees, so we are getting it. So perfect. So this is all about short circuit simulation. You can do it with a spot frequency, or you can use a frequency range. Both way it's correct, no issue. Now for open circuit, let's delete it. Deleting it means it's an open circuit. Our termination is floating now. Now when we'll analyze, we'll get an error, but you can ignore that one because our simulator see that one port is in floating, so it is showing us warning, but you just click continue anyway. Yeah, done. Then report editor, S11 let's see the magnitude part. Magnitude should be 1. From theory it should be 1. So add and display and see magnitude is 1. Now let's try with the phase part. S11 angle, add and display the delete the previous one, delete, and it should be 0. Display, and yeah, we are getting near about 0. Let's see with our data marker. Yeah, it's around 0 because see in y-axis everything is 0 only, so it's 0. Perfect. So I have verified my theory part, what we are getting in our theory with our simulation also. Now let's as I promised, let's try with a complex load. So for complex load, let's take a load of 55, not 55, let it be 100. Perfect. 100 plus J20. So for 100 we have a resistor of 100 ohm. And one thing, when giving unit here, don't give any space, otherwise you might get error. Okay, so without any space we are writing 100 ohm. Okay, now we should get 100 plus J20. Plus means it's an inductor, so get a inductor here. We're getting an inductor. The value of inductor you need to calculate it, because we know the impedance provided by inductor is j omega L, and omega is 2 pi f, and f is 6 gigahertz. So if you calculate it, then it will come around 0.53 nano Henry. So you write 0.53 without any space nano Henry. Okay, now let's connect all the wires. For wire, shortcut is Ctrl W in your keyboard, and for connecting it, left click, again left click, and then right click. It's connected. Let's analyze it. Okay, before that let's change our spot frequency, so like we'll get a nice plot. Perfect. Yeah. Okay, analyze done. Report S11 what is dv add, and we can't know what output you will get, because it's not a standard like short circuit, open circuit or match load, so we can't know before seeing the display, so don't need to guess anything. And let's also plot angle in the same plot, so angle and add. We can plot both the thing together and see display. So okay, so here this blue curve is your dB of S11 and red is your phase of S11. To see blue curve more distinctly, let's do one thing. You just cut it. Again go to report. In report, see here we have axis 1 and axis 2. This is the x-axis. So if you separate the x-axis for both the term, then we'll get a clear visualization of both the curves. So just double click and change it to 2. So angle will come in our second axis. Now display, and see we are getting first axis and second axis. First axis is for angle and second axis is for dB purpose. Blue is with dB and red is our phase, and our constant point is of 6 gigahertz, so you can use right click. So to see exactly in 6 gigahertz, let's use data marker. So click in your required curve, then right click data marker, and you can position it here. So this one is your for dB purpose. Okay, now again right click and exit marker mode. Perfect. Now again click your red curve, because we have not marked our red curve, so click red curve, again right click, get the data marker, and at the required point. Both are point coming in the same plot, so it's better to plot your graphs in separate reports. It will be good, but for now let's try it. So 2 will give you the dB part, the degree part, and 1 is giving you the I may confusing you. Marker 2 is giving you the degree part, the phase of S11, and marker 1 giving you the dB part of your S11. Okay, so I hope everything got clear by now. So by this basics of Serenade is done. From next video I'll start with advanced simulation of Serenade. So see you in next video. Bye bye.